to you live from CHAM, I'm Celia Strumpf.
My name is Owen and today we'll be talking to you about ocean acidification. But what does that really mean? To understand ocean acidification, we first need to understand equilibrium, acids and bases, and the pH scale.
We all know equilibrium to be a state of balance, but what exactly is it in chemistry? Equilibrium is when the rate of the forward reaction is the same as the rate of the backwards reaction. But what happens when equilibrium shifts? According to Henri Louis Le Chatelier, who came up with Le Chatelier's principle, when a system at equilibrium is subjected to change in concentration, temperature, volume, or pressure, then the system partially readjusts itself to counteract the effect of the applied change and a new equilibrium is established.
There are a few theories on what an acid and base is, but to put it simply, an acid is a protein donor and a base is a proton acceptor. In this hypothetical equation, A is the acid and B is the base.
The strength of acids and bases are measured by their pH. An acid has a pH of below 7 and a base has a pH of above 7. pH is the negative logarithm of hydrogen ions. So if a substance has a pH below 7, it has more hydrogen ions. If it is above 7, it has more hydroxide ions. Each reaction with a pH below 7 is 10 times more acidic than the above number. For example, a reaction with a pH of 4 is 10 times more acidic than the pH of 5 and 100 times more acidic than the pH of 6. Pure water is a neutral 7. However, if a substance is added, it can shift to either an acid or a base. If an acid is added to water, the equilibrium shifts to the left and the OH concentration decreases. On the other hand, if a base is added to water, the equilibrium shifts to the left and the hydrogen concentration decreases. Now with live coverage from the ocean, we have Mikey the Science Psyche.
Celia. Hey y'all, how's it going? I'm Mikey the Science Psyche, and let me tell you about ocean acidification. First things first, what is ocean acidification? Well, that's a good question. Anyhow, ocean acidification is a term that is often used to describe changes in the chemistry of the ocean. It occurs when CO2 is absorbed by seawater to make an acid. Let me describe that further for you. Here's a diagram. You see, in this diagram, a lot is happening. The carbon dioxide from the atmosphere can either go into or out of the ocean, as it is an equilibrium reaction. However, the equilibrium is not always 50-50, and in this case, it is more likely for the carbon dioxide to go into the ocean than it is to go out. When the carbon dioxide goes into the ocean, it reacts with the water to form carbonic acid. The carbonic acid then breaks into hydrogen atoms and carbonate ions. Due to extra hydrogen ions, the equilibrium shifts in favor of the bicarbonate. And although the level of calcium remains constant, more carbonate is being used up, meaning there is less to form calcium carbonate. For example, in the North Atlantic, 90% of the carbonate, bicarbonate, and unionized carbon dioxide ion concentration is composed of bicarbonate. Thus, if more bicarbonate was added, the difference would be as inherent because bicarbonate is already the majority. However, if more carbonate were to be added, the difference would be more noticeable because there's much less of it.
That's all very interesting, Mikey. But why does it matter if there's less calcium carbonate?
Well, that's a good question. Well, many different types of shells and corals in the ocean are composed of calcium carbonate. So if there's less calcium carbonate around in the ocean, the shells and corals cannot produce and lose their structure. This is evidenced through an experiment I recently did. I placed a shell in hydrogen chloride and water, which had a pH level of 1, so it was a very strong acid. After one day, the shell was already noticeably weaker and less stable. Shells don't thrive in acidic conditions, and when carbon dioxide enters the seawater, it becomes more acidic. Since the Industrial Revolution, the pH level of the ocean has dropped by 0.1, which is roughly 30%. So, to look at the bigger picture, ocean acidification is severely and fatally affecting the state of shells and corals in our ocean. And if those organisms don't survive, the organisms eating those won't either. Let me remind you that eventually, even we survive off those organisms.
Don't change the channel. We'll be right back with our Bio for Beginners segment.